Recorded, we're open. It's Thursday, November 20th. So today, tomorrow, you guys look at this checklist. You guys turn in your COVID contribution plan. You guys, this textbook, momentum puzzles. These right here. Actually, I do want to go over one of these with you guys because there was one that I had a few questions about yesterday. Different too. Your guys, the take home momentum quiz. If you want to turn that in before the break, then that would be on your mind. Check book it, make sure that you're not missing anything. If you are, good opportunity. Make that up. Okay, I got some board games after you guys, books, Legos, and then when you guys come back from the break on Tuesday, so the day after you guys come back on Tuesday, there's fast testing. So guys and fifth graders especially are taking this test. So guys, just a few minutes here. So that testing info is of course on Google Cloud. Oh, there is testing in the room. So here's my current 3 location. All right, you guys take a good look at that. Look at that.
It did not work.
It posted on Google Classroom. Yeah, guys, all this information is on Google Classroom. And some of your other classes might also be relocated, especially the first 2 classes. Right, so all that information is on Google Classroom. Right, you guys got that? Right. So the one textbook puzzle I want to give with you guys is this one right here. It's this number 3. It has this table of values. So there's this cart that's rolling. I'm assuming it's inside object. 0.5 kilograms. Right? So, right here, this 0.5 kilograms. This was on wheels. Okay? Yeah. And they're recording what's the force as a function of time. Okay? So they got these half-second intervals. So go 0 seconds, half second, 1 second, and so on all the way to 4 seconds. And then what's the force in newtons? Now, do you guys see that these forces are really, really close to whole number values? They're off by a little bit. So 2.01 newtons. Guys, can you basically call that 2 newtons? Can you do that? Right. You guys, same thing for the AP exam. I've seen AP do exactly the same thing. They say, hey, it's like 2.01. They say, okay, well, I'm going to round that to 2 because it's so close. It doesn't really change the answer. Right? Right. Okay, so we get all these values. And then the question is, what's the best estimate for the change in velocity of the object? Oh, change in velocity. And they gave me forces and times. Right? Do you guys remember that? Oh, so mass times change of velocity equals force times time interval. Right, you guys remember that? Right. Well, force times time interval, couldn't that be the area under a force versus time graph, which I'm about to put together with you guys? Right. So if they want the change of velocity, all you have to do is take that area. Right. Guys, what's the calculus term for area under curve? Starts with an I. Integral. Integral. Right. And then divide by the mass. That would give you the answer, wouldn't it? Right. So let's put this together. And so, for the first second, it's all at 2 newtons. 2 newtons, 2 newtons, 2 newtons. Okay. So I'm going to label time and seconds. Okay. You guys notice I labeled variable unit? You guys see that? Variable unit? Guys, pay close attention. Because, guys, yesterday on your coefficient and restitution lab, not a single student labeled units on their graph. Right. So, guys, time is in seconds. And then you put force and newtons up here. Make sure whoever's reading your graph, they don't have to resort to a table to understand it. They can look right at your graph and say, oh, yeah. All right, so that variable is not unit part. So we scale this. Also yesterday, you guys were pretty good at scaling your axes, but not everybody was. So, guys, in this class, do all your axes start at 0, 0? Yeah. All right, and then you scale linearly from there. So I'm going to go 1, 2, 3, 4, 5 newtons. Right, see, notice I didn't skip. I didn't say I'm going to go from 0 to 2 and then skip. Right. And then 3, 4, 5. Right, and then same thing for seconds. I'll go 1, 2, 3, 4 seconds. Right, something like that. Right. So notice I didn't skip a bunch of time. Right, because if you skip a bunch, right, then the graph relationships don't show up like they should. Right. So this class always starts 0, 0 and scale linearly after that. Right. And the exceptions in the real world are not super applicable to this class. Right. So at right, there was 2 Newton force, and then a 2 Newton force, and then a 2 Newton force. Right. Then at 1.5 seconds, I have a 3 Newton force. That's right there. Then at 2 seconds, got a 4 Newton force. That's right there. Right. And then at 2.5 seconds, about 5 Newton force. And then at 3 seconds, a 4 Newton force. Right. And then 3.5, we're back to 2.99. I'll just call it 3. So 3 newtons. Right. And then at 4 seconds, we're down to 2 newtons. Right. And that's the entire story. Because that's all the data plotted. You guys see that? Right. Now, could you, of course, connect all the dots here, connect the dots. One of my classes, they asked for a connect the dot. assignments. Oh, that would be calm and relaxing. Oh, there you go. I connected the dots. Okay. And then, as you're saying, the area under this curve represents the impulse, right? Force times time. Look at that. Now I can break this up into two shapes. How about a triangle sitting on top of a rectangle? You see that? Okay. So it's that. Guys, what's the area of this rectangle? Yeah, base times height. 2 times 4 is 8. At 8 Newton seconds there. Right? Newton seconds gives you Newton seconds. Okay. Oh, this triangle. So it's just 1/2 base height. What's this base equal to? 3. Right? And what's the height equal to? Also 3. 3 times 3 is 9. Divided by 2 is 4.5 Newton seconds. Okay. So altogether, the force times time interval, right? Well, here's the calculus notation for that. Right, what's that? Is was that 12.5 Newton seconds? 12.5 Newton seconds. Okay. And then we're saying, hey, if you take that impulse and divide by the mass, that would give you a change of velocity. So change of velocity would be 12.5 Newton seconds. But which is also, guys, is that also kilogram meter per second? Can I write that? Here, let me see if I can. It's kilogram times meter per second. It's the same thing. And they told us the object or the cart was 0.5 kilograms. 0.5 kilograms. And so would that be yeah. Okay. 25 meter per second. Okay. Yeah. They said which one is closest, so you just pick one that's closest. Right. So that.
All I'm saying is, they did all of that.